to this point, we have found probabilities where x varies normally when the mean is 0, the variance is 1, or the standard deviation is 1. This is read x is distributed normally with the mean of 0 and variance of 1. For normal distributions other than this, where the mean is not 0 and the standard deviation is not 1, we perform a transformation on the variables to reduce the curve to this distribution. Once we have done this, we can use the table of values. So, and I'll demonstrate with this example. If x varies normally with the mean of mu and a variance of sigma squared, then we do what you're used to this. This is the z-score calculation. Okay, the z variable, when we convert our variables to a z variable, then we can use the table. This is so we can use the table. This transformation is so we can use the normal distribution table, where the mean is 0 and the standard deviation is 1. Okay, so the reduction of a distribution is called standardizing. And before we find the probability x is less than 63, we have to standardize this value so we can look it up on the table. Okay, so watch. See, I can't look up the probability x is less than 63 on the table. I can't do that, right? Because this is not a mean of 0 and it's not a standard deviation of 1. So what I do is I go probability x is less than 63 is equal to, I convert it to a z-score, z-score, and you remember that is your x value minus your mean divided by the standard deviation, and this is equal to the probability z is less than negative 0.5. Now I can look it up on the table. All right? So I guess now the table's, if I look up negative 0.05, it's 0.3085. Mm-hmm. Oh, hold it. What is the point of, where do you see that?
The numbers on the top.
Oh, that's if, actually I will demonstrate, oh, maybe the numbers on the top. So, for example, if I want the probability x is less than negative 2.0, I just go here and I read it off, right? That's 0.0228. But if I want the probability x is less than negative 2.15, then I go, okay, negative 2.1 is there, but to get the 5, I read it off there. And so that would equal 0.0158. That's when I have two decimal places. I get that second decimal place across the column. Okay, let's look at this guy. Alrighty, so the probability 70 is less than x is less than 80. Well, you know that's the probability. Here, let me draw a picture of this so you can see it. Because on your test, you're going to have to draw some pictures for me. The mean is 72, and we're going between 70 and 80. So we want this area here, right? That's the area we want. So this is the probability x is less than 80 minus the probability x is less than 70. And I'm just going to make that a little bit clearer. This is 72. Okay. The probability x is less than 80 minus the probability x is less than 70. Now, I can't look this up on the table because I haven't standardized it, right? I need to reduce this to a mean of 0 and a standard deviation of 1, and I do that with z-score. So that's equal to z is less than 80 minus 72 over 5 minus the probability z is less than 70 minus 72 over 5. And that's the probability z is less than 1.6 minus the probability z is less than negative 0.4. And if you look those values up on the table, you get 0.9452 minus 0.3446, and that's 0.6006. So far, so good? Let's do a problem. A machine produces an engine part to a mean length of 51.15 millimeters and a standard deviation of 0.70 millimeters. Assuming the distribution of the part lengths to be normal, determine the following. What percentage would be rejected at less than 50 millimeters long? Let's draw a picture of this. We have a mean length of 51.15 and a standard deviation of 0.7. Assuming the distribution, determine the probability that it would be, so any of these items less than 50 would be rejected. So let's put our 50 here. So we're finding this area. It's just a rough sketch. The probability x is less than 50. Well, I can't look up 50 on the table because the table is for a mean of 0. So we go is equal to the probability z is less than 51.15 minus, sorry, I'm doing it backwards. It's the x value, right, minus the mean. So it's 50 minus the mean all over 0.7. That's equal to the probability z is less than negative 1.64. So there's your z-score with 2 decimal places. So now we have to use the columns, right? So can you guys look that up and tell me what you get? Negative 1.64.
0.0505.
Perfect. So about 5% of the engine parts would be rejected. Okay, so far you've been finding the probability of a normal distribution given a certain z value. What if, now we have to learn how to work the other way around. How do we find the z value if we know the probability? So for example, the probability z is less than c is 0.975. what is C? What is the z-score? So we have to work backwards. Let's go to the table. We're going to look up 0.975 in the probability and figure out what z is. We're going to pick the closest one, 0.975. Oh, there it is. There's 0.975. Can you tell me what the z-score is? Huh? Our z-score is 1 point, there, 1.96. 1.96, right? There's 0.75, so it's 1.96. Your eyesight has to be good on the next test, right? Probability Z is less than 1.96 is equal to 0.975. So C equals 1.96. Let's try this one. What is the C value for 0.3669? 0.3669. Uh-oh. It's on the other side. 0.3. Oh. Yeah. So there it is there. 0.3669. Negative 0.3. What? Right. Negative 0.34. So we're just working backwards, that's all. So probability Z is less than negative 0.34 is equal to 0.3669. Or in other words, C is equal to negative 0.34. Ooh, greater than, well, let's draw a picture here. If it's greater than 0.5, if that's our mean, so this is going to be 0. No, this is 0.1, oops, hold it. The probability, this whole area here, this area here is 0.5199, right? And that's when we need to calculate our C value. Any ideas? How are we going to, the table gives areas to the left, so are we going to look up 0.5199 or what are we going to look up? We have to look up this area. How do we find this area? 1 minus 0.5199 is equal to 0.4801. Wow, 0.4801. This is 0.4801. Zero 0.4801. Let's see, 0.4801. There it is. So it's, there it is right there. 0.4801. So it's negative 0.05. Negative 0.05. Uh-oh. So it's symmetric, negative C, positive C. Can I explain anything better here? Are you okay? So here it is. Now what do we do? Table gives areas to the left. Can we calculate what these areas are? My diagram's not drawn to scale, that's for sure. So I'm going to go 1 minus 0.1010 divided by 2. 0.44. This is 0.4495. This is 0.4495. Can you tell me what C is? Let's give it a try here. .4495. We're just going to pick the closest one. 0.4495. That's like 27 above 0.4495. This is 17 below. We're going to pick the closest. This is the closest one. No, don't do that, please. This is approximated already. We're going to just be splitting hairs. So this is good. Just pick. This is my rule. Pick the closest one. That's what I want you to do on the test, okay? So this is negative 0.13. Negative 0.13. So we can write here probability negative 0.13 is less than Z is less than 0.13 because it's symmetrical is equal to 0.1010. In other words, C is equal to 0.13. Good? And I think there's one. Thank you for your patience in having 2 lessons in one day. You're handling it very well. One more example and then we'll be finished. Huh? Yeah. I just noticed some people are squinting, so I zoomed it in. Okay, let's do it. On a certain cherry farm in the Niagara region, 5% of the cherries weigh more than 8.5 grams. Okay, let's draw a picture of all this information they're going to give us. So, X, we'll call it X2 equals 8.5 grams. 5% of the cherries weigh more than 8.5 grams. So that's 0.05 in that little area right there. 7% weigh less than 5.1. So X1 equals 5.1, and that's 0.07. If the masses of the cherries are assumed to be normally distributed, what is the mean and standard deviation? Uh-oh. Well, if this is, we need, in order to find, we're going to be using Z-scores, right? And then we'll get 2 Z-scores, and we'll be able to get 2 equations with 2 unknowns, and then we can solve for our mean and standard deviation. Okay, let's do it. I guess I'll start out here. What is the z-score for 0.07? Can anyone look it up? Pick the closest one. The z-score for 0.07. Anybody have it? Nobody? Nobody helping me out there in student land? 0.07? Let's look. 0.0668. Here's 0.07. So it's between this guy and this guy. Which one is the closest one? That's 8 above, that's 6 below. Negative 1.48, right? This is the closest one, right? This is 8 above 0.07, this is 6 below 0.07. So this is negative 1.48. So this is negative 1.48, and the area below this is 0.95. So what's our z-score? Now this one's an exception because it's right halfway in between, right? Let's look it up. Let's 0.95. 0.95. 0.95. Where are you? Here. Okay. This is 5 above, 5 below. I don't mind if you take an average of that one. Let's take an average of that one. This is 5 below, 5 above, so we're going to take, it's going to be the average between 1.64 and 1.65. Agreed? 1.64 and 1.65. 1.64 plus 1.65 divided by 2, and this is equal to 1.645. Okay, so our Z2 is equal to that. So let's set up our equations. Negative 1.48 is equal to 5.1 minus the mean over the standard deviation. So I'm going to simplify this a little bit. Negative 1.48 sigma is equal to 5.1 minus the mean, and that will help us when we solve by elimination. Okay, that's really our first equation. Then working on our second equation, we have 1.645 equals 8.5 minus the mean over the standard deviation. 1.645 sigma equals 8.5 minus the mean. So that will be our second equation. Let us solve. We'll take it up there. So we'll go number 1, negative 1.48 sigma equals 5.1 minus the mean. 1.645 sigma equals 8.5 minus the mean. 1 minus 2, negative 3.125 sigma equals negative 3.4. Sigma equals 3.4 over. It's just now the simple algebra that you learned in grade 10. Is approximately 1.088 grams. We have our sigma. Now let's find our mean. Sub into 1. Negative 1.48 times 3. I'm going to use the more accurate one because this is rounded off. If we solve for the mean, we get approximately 6.71024. Therefore, the mean is about 6.71 grams, and the standard deviation is 1.09 grams. Can I explain anything better? Or just working backwards? A very good question. We'll just do part B and then we're done. B. What percentage of the cherries are over 7 grams? We want X is greater than 7, and I think you know how to do that. That's 1 minus the probability X is less than 7. That equals 1 minus the probability Z is less than 7 minus our mean of, I'm going to use a more accurate value so we don't lose in rounding, all over 1.088 equals 1 minus the probability Z is less than 0.27. And look it up in the table. You could take my word for it. And that is about 0.3969. About 39.69% of the cherries weigh more than 7 grams.